Good morning.
Good morning, sir.
Very good morning. Can you hear me clearly?
Yes, sir, audible.
Okay, fine. Let's start. This is a new module. It's actually fifth module. It is a numerical module. So keep a notepad, pen, and a calculator with you, without which we cannot solve problems here. To start with interpolation. Interpolation. Interpolation is nothing but a process. This is a process of finding the dependent variable y for a given value of x. X will be given and a set of values of x and y will be specified like this: x, y. Here x takes different values: x0, x1, x2, x3, etc., xn. And x will be equally spaced, that is distance between x0 and x1, distance between x1 and x2, distance between x2 and x3, and so on. Distance between xn minus 1, xn will be same. X is equally spaced. Corresponding y will be corresponding to x0, the value of y will be y0. Corresponding to x1, it is y1. Corresponding to x2, it is y2. Corresponding to x3, it is y3, and etc. Corresponding to xn, it is yn. You will be given a set of values of x and y like this. The process of finding the value of y for any given value of x in this interval is called interpolation. The process of finding the value of y for a given value of x which lies between x and x0 is called interpolation. And the process of finding the value of y for a given value of x outside this interval x0 to xn is called extrapolation. If x lies in this interval, the process of finding the value of y is called interpolation. If x lies outside this interval, and the process of finding the value of y is called extrapolation. Here we come across two kinds of problems. First, you mark this interval, midpoint of this interval. Suppose this is the midpoint. This is the midpoint. Interpolation means finding the value of y for a given value of x. If this x lies to the left of this table, then we call it as forward interpolation. If x lies to the right of the table, we call it as backward interpolation. If x lies in this part, we call it as forward interpolation. If x lies here, we call it as backward interpolation, and we have different formulas to find backward and forward interpolation. Let's see. First, you make a note of this definition. The process of finding y for a given value of x between x0 and xn is called interpolation. The process of finding y outside the given range x0, xn is called extrapolation. We have different formula for interpolation and different formula for extrapolation. Newton's forward interpolation formula. Newton's forward interpolation formula. It is given by yr, or you can write it as f of x. In either ways you can write yr is equal to this one, or f of x is equal to y0 plus r into del y0. I will tell you what is del y0 while solving the problems. R into del y0 plus r into r minus 1 divided by 2 factorial into del square y0 plus r into r minus 1 into r minus 2 divided by 3 factorial into del cube y0, and it continues, where r is given by x minus x0 divided by h. I'll explain these components while solving the problems. This is applicable when x lies to the left of the table. And Newton's backward interpolation formula is yr, or you can call it as f of x, is equal to yn plus r into inverted del yn plus r into r plus 1 divided by 2 factorial into del square yn plus r into r plus 1 into r plus 2 divided by 3 factorial into del cube yn, and it continues, where r is given by x minus xn divided by h. And this formula is applicable when x lies to the right of the table. You note down these two: Newton's forward interpolation formula and Newton's backward interpolation formula. Let's solve a problem. We will come to know what actually these interpolation formulas or problems are. This is a problem. Find y of 1.4 given that x takes values 1, 2, 3, 4, 5 and y takes values 10, 26, 58, 112 and 194. Find y when x is equal to 1.4. This is the problem. Find y when x is equal to 1.4. First, verify whether x is equally spaced. Distance between these 2 points is equal to 1. Similarly, distance between these two is equal to 1. Distance between these two is equal to 1. And distance between these two is equal to 1. X is equally spaced. And these are the corresponding values of y. And we find y when x is equal to 1.4. Find y when x is equal to 1.4. This is the problem. Here we construct a table first. We have to construct a table that is called a difference table. First column is for x and second column is for y. Here x takes values 1, 2, 3, 4, 5. These are the values attained by x. Corresponding values of y are 10, 26, 10, 26, 58, 112 and 194. Corresponding values of y. Now we construct a column for first order differences. We call it as first order differences denoted by del y. Start from this last number, 194 minus 112. We calculate 194 minus 112, that is equal to 82. Right in between 194 and 112 like this, 82. Difference between these two. Last one, 194 minus 112. Similarly, 112 minus 58. Tell me the answers. 112 minus 58.
54.
54. Right between these two here. Similarly, 58 minus 26.
32.
32. Right in between 58 and 26 here. 26 minus 10 is 16. These values are called first order differences. Next we write second order differences, del square y. Del square y. Del square y. Similarly, 82 minus 54. 82 minus 54 is 28.
28.
Yes, 82 minus 54, 28. 54 minus 32. 54,
22.
22. 32 minus 16. It is 16. These are called second order differences. Next, third order differences, that is del cube y. Del cube y. 28 minus 22. 6. 22 minus 16, that is also 6. Next, fourth order differences. It is obviously 0. 6 minus 6 will be 0. This is called a difference table. For writing this table, you get 3 marks in the examination. 3 marks. Now we calculate R. After construction of this table, we have to calculate R. R is given by what kind of interpolation is this? Forward or backward? X is equal to 1.4. First mark midpoint of this table. This is midpoint. 3 is the midpoint, right? Here we have 2 ordinates. Here we have 2 ordinates. 3 is the midpoint. 1.4 lies between 1 and 2. 1.4 lies between 1 and 2. That means it lies to the left of the table. Therefore, forward interpolation is appropriate here. Forward interpolation formula. In case of forward interpolation, R is given by x minus x naught divided by h. In case of backward interpolation, it is x minus xn divided by h. In case of forward, it is x minus x naught divided by h. This is equal to x. X is 1.4 minus x naught. X naught is equal to 1 divided by h. H of length of each interval. 2 minus 1 is 1. 3 minus 2 is 1. 4 minus 3 is 1. 5 minus 4 is 1. Therefore, this is equal to 0.4. 0.4. Note on this table. Now we calculate YR. YR, or you can write it as f of x. X is 1.4. 1.4. What is the formula? Forward interpolation. Y naught plus R into del Y naught plus R into R minus 1 divided by 2 factorial into del square Y naught. Expand up to del cube Y naught, because del power 4 Y naught is 0. You need not consider it. What will be the next term? R into R minus 1 into R minus 2 divided by 3 factorial into del cube Y naught. Del cube Y naught. R is equal to 0.4. Substitute the values. R is 0.4. In case of forward interpolation, we consider these values. These values. In case of forward interpolation. In case of backward interpolation, we take these values: 82, 28, 60. In case of forward interpolation, 16, 16, 16, 60. I substitute. Therefore, YR, or you can call it as f of 1.4. This is equal to Y naught. This is Y naught, Y1, Y2, Y3, Y4. Y naught is 10 plus R into del Y naught. What is R? R 0.4, correct? R is 0.4 into del Y naught. This is del Y naught. Del Y naught is 16 plus R into R minus 1. R is 0.4 into R minus 1 is 0.4 minus 1 divided by 2 factorial. That means 2 into 1, 2 into del square Y naught, and del square Y naught is also 16 plus R into R minus 1 into R minus 2. R is 0.4. R minus 1 is 0.4 minus 1. 0.4 minus 2 divided by 3 factorial. 3 factorial is 3 into 2 into 1, 6. into del cube y naught, and del cube y naught is 6. Del power 4 y naught is 0. You need not take it. Now take a calculator and simplify this. What is the answer?
10.096.
10 point. No. You do it again.
14.096.
14.096. No, decimal points are not correct.
14.864.
That's right.
64.
14.864. This is correct. These are very simple problems. If you commit mistakes in these kind of problems, no excuse. 14.864. Do it carefully. Is this clear? ಅರ್ಥ ಆಗಿದೆಯಾ?
Yes, sir.
Okay. We'll move to the next problem. First, make a note of this. This is the table, difference table. And this is calculation of R and substitution. Answer is 14.864. Use an appropriate interpolation formula to estimate y is equal to f of x for the given values of x. What is x? 1.85. Find y RF when x is equal to 1.85. 1.85. What kind of interpolation is this? First, mark the midpoint. This is the midpoint. 3 ordinates to the left and 3 ordinates to the right. Where is this 1.85? 1.85 lies between 1.8 and 1.9. That means to the left of the table. Forward interpolation is appropriate, right? Forward interpolation is appropriate here. First, let's construct the table x, y. Here x takes values 1.7, corresponding y 5.474, 1.8, 6.050, 1.9, 6.686, 2, 7.389, 2.1, 8.166, and 2.2, 9.025. Given values. First order differences. First order differences. Start from last order rate. 9.025 minus 8.166.
0.859.
0.859. That's right. Next, 8.166 minus 7.389.
0.777.
That's right, 0.777. Next, 7.389 minus 6.686.
0.703.
0.703. Next, 6.686 minus 6.050.
0.636.
Yes, 0.636, right. And 0.050 minus 5.474.
0.576.
0.576. First order differences. Next, second order differences. 0.859 minus 0.777.
0.082.
0.082. 0.777 minus 0.703.
0.074.
0.074. Okay. 0.703 minus 0.636.
0.067.
0.067. Next, 0.636 minus 0.576.
0.06.
0.06. Next, third order differences. Third order differences. 0.082 minus 0.074.
0.008.
0.008. Okay. Next point.
0.007.
0.007. That's right. Point 0.067 minus 0.06 must be 0.007. Third order differences. Next, fourth order differences. 0.008 minus 0.007 is 0.001. 0.007 minus 0.007 is 0. And last, fifth order differences. 0.001 minus 0 is 0.001. This is the difference table. And in case of forward interpolation, R is given by x minus x naught divided by h. X minus x naught. X is 1.85. The value of x at which y is to be determined. This is x 1.85 minus x naught. Minus x naught. This is x naught, x1, x2, x3, x4, x5. X naught is 1.7 divided by h. Length of each interval. 1.8 minus 1.7, 1.9 minus 1.8, 2.0 minus 1.9, 2.1 minus 2.0, 2.2 minus 2.1. All are equal to 0.1. Therefore, R is equal to
1.5.
1.5. That's correct. R is equal to 1.5. Now we write forward interpolation formula up to fifth differences. Forward interpolation up to fifth difference. YR, or I can call it as f of 1.85 is equal to y naught plus R into del y naught plus R into R minus 1 divided by 2 factorial is 2 into del square y naught plus R into R minus 1 into R minus 2 divided by 3 factorial. 3 factorial means 6 into del cube y naught plus what will be the next term? R into R minus 1 into R minus 2 into R minus 3 divided by 4 factorial. 4 factorial is 4 into 3 into 2 into 1, 24 into del power 4 y naught plus next term will be R into R minus 1 into R minus 2 into R minus 3 into R minus 4 divided by 5 factorial. 5 factorial means 120. 5 factorial into del power 5 y naught. You write it properly. I do not have much space here. Into del power 5 y naught. You write it properly. Del power 5 y naught. R into, is this clear? R into R minus 1, R minus 2, R minus 3, R minus 4 divided by 5 factorial into del power 5 y naught. What is del y naught here? Y naught is 5.474. This is y naught, y1, y2, y3, y4, y5. Y naught is 5.474 plus R into R is 1.5 into del y naught 0.576. This is forward interpolation. Therefore, we take these values. Del y naught is 0.576. Del square y naught is 0.06. Del cube y naught is 0.007. And del power 4 y naught is 0. This is 0 and 0 into anything is 0 this term. Plus del power 5 y naught is 0.001. Substitute and simplify. This is the table. Do it carefully, do not make mistakes.
Five point 496.
8.496. No, it is 6 point something.